Alright, yes, so we're going to look at chapter 9, which is learning unit 2, and that is all about counters. The first counter we're going to do is on asynchronous counters. Counters are divided into two groups of counters. You get asynchronous counters and then you get synchronous counters. Asynchronous, the term asynchronous refers to events that do not have a fixed time relationship with each other and do not occur at the same time. The flip-flop within the counter do not change states at exactly the same time because, and this is important, they do not have a common clock pulse. Okay, I'm going to show you with the diagram. You will see that the clock goes into the first flip-flop, and then from there on the second flip-flop is clocked from the output of the first flip-flop. Yeah, some of the outcomes that we have to achieve during this section is that we're going to look at the operation of a 2-bit asynchronous counter, a 3-bit, we also have a 4-bit that we will show you. We don't go higher than a 4-bit. We're going to look at the ripple in relation to counters, describe the operation of a decade counter that we're going to build, and then also develop counter timing diagrams. The counter timing diagrams is important because that's what you're going to use when you answer the questions in the test, because you have to develop the diagrams yourself, the timing diagrams. Alright, before we can look at counter, we will just look at the counting sequence again. Just to refresh your memory of what is a counting sequence. Now if you have 2 bits, right, because we use bits to count with, we know with 2 bits you can count how far. How far can you count with 2 bits? You can count from 0 to 3. Yes, you can count from 0 to 3, which gives you 4 counts. Okay, that is important that you always distinguish between that. So although we count 0, 1, 2, 3, that gives you 4 counts because we start counting at 0. And there's our binary values. When we work also with a counting sequence, we consider Q0. This is your least significant bit, and then Q1 is your most significant bit in this case. It starts off with 0, 0, 0, 1, 1, 0, 1, 1, which is 3, so that will then equal 0, 1, 2, 3, and then after that it recycles back to 0 again. Right, and that's a total of 4 counts. And we'll also need to count 4, you will need 4 clock pulses. So